Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. I was working a little bit on the Medusa function that we were looking at yesterday, and that's what we're going to continue on today. Got quite a bit further, and I think we may be able to finish it out. And then I did some work on this duplicate finder tool as well, and have several pieces together that I think will make this useful in the future, and it's coming together pretty nicely, I think. So if you're not familiar with Castlevania Symphony of the Night, you can go to soten.z.dev, where you'll find progress on several of the overlays that we've been working on. You'll also find a link to a GitHub repo with all of the uploaded code that's been decompiled so far. And you'll find a link to the Discord server where we're chatting about tooling and decompiling and the game and things that we've learned along the way. So we had started working on the last of two unique, the last of the unique functions in the Medusa cutscene, Medusa boss fight. When we were working on the split yesterday, though, it looks like there may be one additional function that is appearing after shared code, and we'll have to take a look at that as well. We actually can use the tooling I was just talking about to see if that's a duplicate of something else that I'm not familiar with. So we had started with the PlayStation version, but then I moved over to the PSP version, and the PSP version, as always, has been extremely helpful. And it's actually closer now on the PSP version than the PlayStation version, which isn't typical. Usually the PlayStation version is more liberal in what it will accept, but in this case, the PlayStation version the PSP version is winning the day. And as we get closer there, I think we'll get closer on the PlayStation side as well. So this morning I was going through and cleaning a bunch of this up, getting rid of most of the temporary variables. And so what's left, there's one section down here where instructions aren't lining up, and I'm not quite sure what the logic is supposed to be. So we'll have to take a look at that and see if we can solve that part. And then register allocation, which hopefully when the instructions line up, the registers fall into place as well. I had started going through, and this is often a problem on the PSP version, and less so on the PlayStation version. To remind anyone, or if you're new to the stream or to any of these uploaded older episodes, the PlayStation version of Symphony of the Night is compiled using GCC with standard optimization. And so we'll see out of order code that is you'd often write on a single line, but is split into multiple pieces, and other things that the optimizer does to reduce the amount of total code. The PSP version is compiled with a MetroWorks compiler, and most of the overlays that we've come across so far are compiled without optimization, which ends up being very favorable for the decompile process, because we see a very linear set of instructions, and most of the time there's enough additional data there that we can tell what is going on, and it's to the point where there's code that would be optimized out of the PlayStation version. You'll see assignments and other things that aren't necessary, and so they're thrown away on the PlayStation side, but they remain on the PSP side. And so we can have one set of code then that works on both, just with the two different compilers. All right, so I was kind of going through and annotating some of these registers. So the way that the PlayStation and GCC compiler works, it will start allocating registers as variables are being used or as it needs the space for those variables, whereas the MetroWorks compiler in the unoptimized form will come through and kind of assign registers to variables the way that they're declared. It also seems to declare things based on their size. So it'll chunk similar size variables together and put them in an order. And so we can, by looking at the register names, we can look at what order those might have been declared. Lion Guru, thank you so much for the Prime sub. Definitely appreciate it. One of the things that I'd like to do with subs and anything that these streams or videos make is kind of put them back into this project and make sure that we have all of the right resources that we need, so that we're doing things by the books and there's no infringement or anything like that that's happening along the way. Orcam, good to have you back as well. So I'm going to go through and look at the places where registers are different. That's the R difference in this current column. And see where either I haven't annotated a variable yet, or maybe I have annotated that value, and we got the hype train incoming. Or where I have annotated a variable and maybe a different variable is being used. And this is one of those cases where we're using S7, but the original code is using V0. And so we can kind of, oh, thanks, Orcam, really appreciate it. So we can go through and kind of annotate this primitive, let's see, this is the, this jump. So we don't have a variable specifically for that, so we can't use that directly. But then there is this prime index, or primitive index, and that one does look like it is S8. So we will annotate that one there. Hey Roman, good to have you back. So as we go through, there's we can't necessarily force these indexes, but we can kind of massage the declarations so that they kind of bend to our will. And we'll see if those work out or not. So down on line 33, this primitive is getting stored in S0, it looks like eventually. And I know Miss Murphy has mentioned it on the stream before, which order these tend to go in, and I can't recall offhand which one it is. But we'll try to figure it out. There are still a few things that are a bit off. 43 here is there's a load immediate down here, but that is not. Ah, I see. So It's not quite right either. So we're loading V1. We're doing the shift. That's right. And then we're subtracting. But we're subtracting a variable. And so usually I like to call this brightness. And we'll see if that... So what's happened here is that I'm spilling registers. So let's see if it will... So I'm pretty sure that this is the pattern that's being used. We're loading this value, but I have too many too many variables, so we're spilling onto the stack. I'm going to try reusing one of the variables that I have there already, and if we can split that up later, then that's great. Otherwise, yeah, and that seemed to work fine. So in this case, we're looking at this is just being put in the temporary V1. So we'll have to split that out somehow later, but I'll go for the match right now. Yes, you are right. Roaming points out that I have my subtraction wrong. I was too focused on getting it into a variable, and now it's correct. So I want to make sure that S4, or in my case V1, is the second side of this. It's a little odd that these got flipped around. So Roaming is suggesting flipping it. Let's see if that ends up working. Yeah, so we need the ordering is the issue. So we do need that. Now am I wrong? Maybe I'm wrong now. No. So Biz Murphy's pointing out that temp variables typically go in S registers, whereas intermediates go into the V registers. Yeah. Let me look at this one more time. So we're subtracting V1, so C0 from S4. Yeah, I'm actually surprised that is being forced into a register or a variable. Oh, I don't know what I had before, but this seems to line up now. Let me go back and see what I had. What did I do wrong here? Oh, it was plus. There we go. Subtract, and then you get the right thing. So the A0s, if you're not not calling a function anytime soon. The A0s are also used kind of as intermediate values, or in this case it's used for a constant. So here we are, so in the, this is being stored though in an S value, which makes me, which makes me think that it isn't a temporary variable. Yeah, I agree. So, kind of following up on what Biz Murphy says, and kind of how I started at the beginning of the stream, you can, to a certain extent, try to coerce these registers into what you want them to be, but you don't always get what you want. And so down here, for example, on line 48, we're not actually going into any temporary registers. These are all fields on a struct that these are being loaded into, but the way that MIPS works, we can't write one memory address necessarily to another memory address directly. We have to load that value into a register and then write it back to a register, and so they have to choose something. And so in this case, why are they choosing S3 versus something else? Often it's because the compiler thinks we can't overwrite V1 for whatever reason. And so is there a variable that's sticking around, for example, like, this is being reread each time. And it's being overwritten. I'm not sure offhand why these are happening. So I'll just keep going and see what else we can find along the way. I did run into something interesting with this, and I think this pattern is going to end up being wrong. Down here further, we're doing basically the same thing, and I need to rewrite these fields. So this is kind of a odd case where they're in the extension struct. There's an array of, it looks like 12 XY pairs, 16-bit XY pairs, so 32 bits total. And different parts of this function are going to iterate through them forwards or backwards, depending on, actually there might be 13 of them, depending on which way. Yeah, there's 13. So I had originally assumed that this be based on an incorrect assumption about this 84 offset. The size of an entity is 8C. And so in the PlayStation version, when I was looking at this, I thought, oh, GCC is just optimizing this because it's going to be accessing something at the beginning of this struct, and it knows that it doesn't have to go all 8C forward, just to do some other addition to get to the whatever fields that it's looking for. But no, this is correct, and what it's I think I have 8.4 defined on this. It's looking for this unknown 8.4, and it's just a set of offsets, and so we need to fix all these. And so this is going to be plus equals 2 because we're going to be jumping. We're going to be setting an X offset here and setting a Y offset immediately after. And I can name my variables correctly to get the compiler to do what I want. And yeah, I might have not named that what I thought, but I will have to go back through probably and rename this one. It is unknown 84. So all of this, these were pulled originally from, I want to say maybe Succubus entity, and those are not correct. Oh, because I'm not going to the extension. There we go. Yeah, and now all that lines up, and that works out great. So here we see as well, just looking up a few lines, this, and some of these are bizarre to me, why they end up working out the way that they do. But we're next is the 0th offset of primitive. And so all we're doing is assigning the next primitive to the same variable, overwriting the same thing. So we're looking at offset 0 and S0, and then we're going to be assigning it to S0. And the way that we're currently compiling does that as expected, but the original version doesn't. And yeah, I kind of wonder if there's another trick to that. Oh, that's a good point. And yeah, and we see like this instruction down here is on a 16-bit offset. That's a great call out, and not something that I had seen or internalized before. All right, so we got that fixed, and we're getting close. Let's jump over to the PlayStation version just to see. So the PlayStation version is at a meager 83%, but that does get us up to 87. So we're catching up on the PlayStation side. Back to PSP. We're down here. So we have this S7 versus S8 difference, and this is a hint down here where somewhere around line 72, we are, so we're loading this offset of 82 here into S7, and we actually know what S7 is up above. Ours is called S8. And then down below, we're doing a sign extension on that same variable, which is, or sorry, we're loading the result of that into a sign extension of that same variable. So, and that's around line 73. And where was this one? Line 66. So what I think is happening here, I had actually switched these. I'm going to try going back. Oops. I'm going to try going back to what I originally had. So there's, I created a separate variable here because it looked like there may have been a 32-bit value between these, but I don't think that was the case anymore. Let me go back up here and see what I've... so S7 is the angle variable, or it looks like the angle variable. And on ours, it's being compiled right now as S8. That's not anything to be worried about. But the result of these intermediates are being stored to the stack at offset 3C, and let's see if anything else is being stored there as well. Yeah, so this looks like maybe a unique value. So I think we'll create a new variable for that. Do we need a new variable, or will it happen implicitly? So the we're loading this offset 40 from the stack, which I believe is self, into V0, and then offset 80 for V0. So this would be like the first thing after the argument. So I'm going to try doing that and see if we can pull this out into a separate variable and if that makes any difference. Oh, actually, maybe it's inversed. Oh, I have val, a 32-bit value that's down there already. Let's see if that will... Val's a great name, great descriptive variable name. Slightly better. But this is going into a register, and we don't want it in a register right now. We want this pushed back onto the stack. So Val's being given the register S5. Let's make something new and see if we can force that. So this, I'll just call it temp Y. And we were able to force it. We're not at the right offset, but we are on the stack, so that's good. What? Oh my goodness, roaming, you're a genius. All these things. This is the point of streaming is I can learn as much as hopefully I can teach. So I am going to go back up, and I'm just going to put a little marker on that temp Y, saying that we need it at 3C. So maybe we can get back to that later. Oh, that's gonna... That's awesome. I scroll around so much and I miss the code that I'm looking for. Thank you so much for that. All right, continuing on. We're still looking for any register mismatches. We're getting really close though. It's going a little better than I had hoped. So 90, we have this register S6. I have that. Oh, interesting. I have the wrong, possibly the wrong value there, or the wrong variable. So let's fix that and see if that helps us. We're still going to have the wrong registers, but they'll be closer to the right registers. So once we fix those two, that should end up working out. A bunch of this is looking good already. 122. This is the same issue, where if we were able to push those one or the other, yeah, I agree. about the greater than or equal to. I'll go back and fix that later. Uh, I guess we could do this and get rid of the. Make sure all those instructions are correct. I keep meaning to open issues with M2C, but that seems like another one. If the comparison's against something that has the last bit set, it probably is. Or if it's a greater than equal to with the last bit set, or a less than equal to with the last bit set, it probably should be simplified. All right. Usually I miss those and then get dinged in my code reviews. So same thing with those same registers. I might go through and look for, I have S5 already. Well, it's possible that the smaller registers are actually not being used. Oh, yeah, so now this is back down to where I was running into issues before. And so I probably need to find S4. And we actually are using S4 on line 118 here. Oh, and that's X. I had been looking for this, and my guess is that Y is going to be S3, but we'll see. So yeah, I'd been trying to untangle this morning and failing miserably, but now maybe I'll do a little better. So let's go back and find that S4. So we have S3 here, and S3 being used the same way on line 133, and that looks like Y as well, as expected. Yeah, Biz Murphy, if you want to, I know that this stuff, everything here is wrong, and I need to untangle this. But if you want to throw anything out, I'm happy to have it. Oh, yeah. Yeah, thank you. Yeah, I probably wouldn't have figured that out as quickly. I appreciate that. The instructions that get generated, so the PlayStation doesn't have any kind of floating point unit, and often divisions are integer divisions. And this is one of those cases where the instructions that get generated make it look like a bunch of branching and odd variables and other things like that. But it's much more straightforward than it looks, and so you look like a dope when you don't get it. Of course, that's wrong. Oh, that's so beautiful. And look at all that. All those beautiful instructions fall into place. Not quite right. Looks like it's just registers, though. So let's start up here. Yeah, so we're loading into the wrong register. We're using A0 instead of V0. Not terribly concerned with that. And the result eventually gets moved into V0 anyway. This may be that alignment issue again. We'll see. And then an extra move there as well. So I'm not too concerned with that because it does just look like registers and extra moves. So there's some stuff down here that needs figuring out. Down on line 150. It looks like I have subtraction when it should just be an addition. We're loading into the wrong place. Are we doing these out of order? Is that the problem? Yes. That's the problem. There we go. I think the ordering came from the PlayStation version, which I don't know why I would have changed the order. Maybe it's doing these add some subtracts first. Wishmouth. And then doing the rest. I don't know. That seems odd. So there's an add that's in the wrong order on line 158. Looks like all of these are in the wrong order. And what about the subtractions? The subtractions are as well. Oh, and now some of the registers are falling into place. No, these were X and Y. X offset looks like it has now. All right, we have a S2 versus V1 down here. 169 looks like the this was a bad offset from earlier, thinking that this was an 8-bit value. So this is being pulled from into S2. I'm not sure why that ended up going into S2 as the temporary. More of these moves, superfluous moves. That all looks fine. This was a while loop that was compiling fine, and I changed it to a for loop because it seemed to fit the structure. I'm not sure if I can try moving that back. I'm gonna move over to the PlayStation side though and see. This is, yeah, much better already. We'll see what's going on over here. Oh, PlayStation side not happy. What is going on? There must be something I did along the way to differentiate two sections that weren't different before. Most of the time, oh, this should be overturned. Why was that? That seems broken from the beginning. I wonder why that was missed. Helps a little. So this is similar to what is some of the things that are happening on the PSP side. So, some reason this primitive index has spilled. Looks like it's spilled onto the stack. Or, no, I'm sorry, it's loading self from the stack. And then this is out of order. The ordering we get from the PSP side, so I'm reasonably confident about the ordering. But maybe I shouldn't be. And here we see how the optimizer, it'll just move things to wherever it wants. Yeah. And that does make sense. Actually, it makes sense in this regard as well. So I'm going to go over to the PSP side. So Bismurphy's saying, prim index, hey, dope. Prim index is a 32-bit value. And I should know that. But one hint for that is the way that these registers are being allocated all in order. My guess is that this angle is as well. And let's go over to the PSP side. Maybe I'm really off on that, but we'll see. So we'll switch that to a 32-bit. Oh, wow. And what if we change the angle as well? No, the angle's not. I'm surprised by that. But yeah, that clears up a lot of it. So it looks like S3 and S5 may be out of order. Or we're using the wrong variable there. Down on line 35. Oh no, these are these are unrelated. That looks nice though, and we'll see what the PlayStation side looks like. PlayStation side didn't move. If you want to follow along on either of these, I will post this into chat, so you can play along at home. If you've not used decomp.me before, you can open that window and you can, or open that link, and you could edit to your heart's content. You won't be able to save though. So if you've edited and you do want to save your work, click fork, and it will take your current state and copy it into a new document, which you can then save to your heart's content. So I'm going to go through and look at some of these again. Okay, so going back here, is it possible that prim is up further? Where was I? 43. Do I want to mess with this? Before I go through and mess with variable ordering, I am going to so it looks like prim index, yeah, it's just that temporary variable that's coming into S3. So let's go down to 131. So S6 is our X offset. Oh, and that one's right. Oh, this is the same thing. Same thing? No. Oh, dummy. Simple. Simple, simple. So I copied and pasted, copy pasta error. You had X offset where Y offset should be and vice versa. It looks like these are backwards, which makes a lot of sense as I was going through this. I was wondering why... oh, no, these are... so having Y offset first and then X offset is... I think a little odd for arctan, but it is consistent within the function, so I'll go with it. 144. It looks like we're saving to X. So we're just, no. S4, let's go find what S4 is. S4 is X. Yeah, we should be... but we're getting S3. So are these... that corrects that. This is a little strange, though. I just have these backwards. That's why. And so now I'm going to have to flip these back the other way. They were correct the first time. Oh, look at that. So many clean lines. Okay, we're... that may have been it on the PSP side. Oh, so we have a PSP match. So all we have to do is decompile the rest of the PSP version of this overlay. There are still some issues here. So we, on line 73, our player variable is being pulled to the wrong place on the stack. Let's try to move that up one and see if that changed anything. It is not, and I'm going to try to move it. Oops, I'm going to try to move it down. And it's possible that we can get it correct by moving it down. And do we need this temp Y? Did that get used? Yeah. Okay. Is there anything else in this one? I actually think that looks good. So I'm going to bring this over to the PlayStation version. Oh, look at that. The PlayStation version was so far, and you get it right on the PSP version, and 9 times out of 10, it's going to be right here. We do have one issue down on line 76 that we need to try to correct, and hopefully, yeah. So let's see if we can. Let's see if we can move that back. I'm going to do it on the PlayStation or the PSP side. So this temporary, I pulled out. Both decompilers on the PSP side and the PlayStation side had these in line. I'm going to try to put them back in line and see if that works out. Oh, it doesn't. That one doesn't. No. Let's try doing it on the PlayStation side. It's an odd. It's a little odd the way that it is. No, there's still a move that's missing. No party until we got this last one fixed. So there's a couple things that we could try. We could try moving, getting rid of this player variable. See if that's necessary. We could pull this out as well. So we need to figure out why are we moving that into a second register? And is that used again? It's not. Oh, nope. It's just being overwritten later on. So it doesn't seem to be any good reason to have this in S1 to begin with. Yeah, we can throw it in the permuter. Is it a cast? So it's this angle. The angle's already a 16-bit, and it's being cast to a 32. I will attempt that one more time now. So we can force the cast here, but the compiler should be promoting this to 32 bits for the ABI anyway. Yeah, we can throw it into the permuter. I think that's fair. I'm going to move this into the context. I do need to rebuild my context. I mentioned this earlier this week. There's been a lot of nice advancements for many different structs and headers along the way, and I've been using the same context for several weeks. So let's see if we can get this in and see what the permuter will do. And while the permuter's running, come on. There we go. I will oh, I might have this open somewhere else, but that's okay. I might go through and show some of the matching stuff that I've been working on. I need to add this new Medusa. It is possible as well, and just kind of think about this a little more. The way that this entity currently is set up, or the entity extension, I should look for a union. I know that it's not quite correct yet, and does need some fixing. Oh, that's why I was in the wrong editor. So if you're not familiar with the Decompiling, this is a tool that will make small changes to the code and see what happens when it compiles. And if the match is closer, it will. I think that's all I need. It will let me know. Where am I missing? This is boss RBO3. Oh, I was looking at matchings. I need not matchings. So this will go for a while. And we'll see if it comes up with anything. In this case, what I'm hoping for is possibly that there's types or an extra variable or something like that that's causing an issue. Yeah, roaming. I watched the stuff about the object diff, and I haven't looked into it. I should really look into it more closely. I'm going to look at this one more time and just see if there's anything that I missed when going through this PSP version. Mostly what I'm looking for is anything besides these immediate values that are different. There's also sometimes it's less obvious, and I don't think it shows up in the score, but sometimes there's branches that aren't obvious. That would show up here, though. Yeah, I'm not seeing anything. The other one we talked about earlier this week was the cases that were not showing up. Yeah, I don't see anything super obvious here. So I'll just save these off and we'll go back through. All right, so let me see where I was on here. When you're looking at assembly, so this is what I've been working on for the last okay, so Biz Murphy is saying the score should be similar. Oh, sorry, backing up a little bit. The big difference between the decomp.me score and the permuter score mostly goes back to symbols. And so when the permuter's running, it I don't think it's looking at the symbol names. I think it's looking at the values that get generated, right? So here, yeah, we're not looking at GAPI. So kind of to kind of round out what I was saying there. When we're decompiling, one of the things that's helpful is if we have names for addresses that are known known things. So in this case, we have a structure called GAPI, and it has fields that are function pointers, and we know what the name of all those fields are. But when that gets compiled, it gets compiled to a specific address, and the decomp.me doesn't have the symbol table that we have for computing that address. So I'll upload some assembly. The symbol table says that this is g underscore API underscore allocate primitives. But when this code is compiled, it says I'm loading an offset that's similar to GAPI, but then adding a difference in that value. And this is actually somewhat interesting, I think, from a both Splat perspective as well as a lot of these tools. These are independent instructions, and these are just happen to be loading things into the same register. This is loading the upper half of the register. This is loading the lower half of the register. And Splat and Decomp.me and several other tools recognize that that's how on MIPS you have to load a 32-bit immediate value. And so it will do the work to kind of piece those things together. And then treat them as one kind of holistic address. And then M2C comes along and says, looking at the structures that you have defined, this looks like a GAPI, and I'm going to use this particular offset. Oh, no. M2C doesn't do that. Sorry. M2C just gives us the symbol. It just gives us this particular symbol. On the permuter side, what we can look at is the compiled version, which those symbols have been translated into addresses. And I've always assumed that the permuter just looks at the binary, but maybe it doesn't. I don't know. I could be wrong. Let me see if I can clean this up to make this a little more obvious. And actually, I don't need this one. All right. So when we're extracting code from the game using Splat, we get these assembly listings, and the assembly listings have human readable assembly, but we also get a nice version of the machine code next to it. This is little endians, so these are all backwards from what we normally would want, backwards octets. And we can kind of see what this is. Really? It doesn't need to assemble the code, though. It needs to compile it. And from the compiled object, it can pull that offset. I haven't looked into it enough to know specifically what it's doing. So I'm not going to purport to say exactly how the permuter does what it does. I'm gonna. Nothing. I don't know if you can hear this in the background. Nothing says Halloween though, like I'm the Wind. So make sure that you play it at all of your Halloween parties if you're playing the Stone soundtrack. Nice, sexy sax in the background. Set the mood. Okay, so I am not doing a good job aligning these. All right, so when let me see if these line up now. Yes, they do. So when we want to find duplicates in the code, so each of the overlays basically has a set of 80+% of code that's identical to all of the other overlays for stages, and bosses are similar. So we have this create entities below function in every stage overlay, in every boss overlay. And so we don't want to have to decompile those over and over. And I mentioned it earlier this week, but that's why we have the duplicates report that Sozu wrote. It tells us when these functions are similar or identical to one another, but we get some false positives like this: create entities above, create entities to the right. And that's because when you're looking at MIPS instructions, they're constructed in a way that the first 6 bits, when you've reassembled them as a 32-bit value, the first 6, or the top 6 bits, are an opcode. And then, depending on that opcode, that's how you interpret the rest of the 26 bits that are remaining. That that isn't. You should talk to your family. And Biz Murphy's saying that I'm the wind. There are some obscure songs that I always think, oh, that'd be nice to have at my funeral one day. And I don't think I Am the Wind is one of those. But he closet Soten fans in your family. I wonder if he really loved the game. So what our dupes tool does is look at those opcodes and creates a string of opcodes for a function, and then looks at all of the other functions in the game and tries to find whether or not that that same string of opcodes exists. Or it does a Levenstein distance, and that's how we get things that are not quite 1.0. Let me find some of those. Like these down here. These are very close, but not quite the same. And it's actually very efficient to do that because basically however many instructions you have in a function, you can divide that by 4 and have a string of that size, and that's pretty efficient to do searches for those things. But it does take a while when you're doing the cross product of all those. And so this is actually used then as well when we're doing new overlays to find whether those functions exist. But we run into some false positives because things like create entities above and create entities to the right, they're unique functions, but they match the same because all of their operation codes are the same. And part of that comes from ALU operations all having the same opcode, and then using the last 6 bits, I think it's 6 bits, to encode what that function is, whether it's a subtraction or anything like that. I doubt that there was pro Soten back then, but hey, thank you, Entropy Gravity. Well, really appreciate it. But I wonder if maybe if you have a cousin or something like that was a gamer that thought maybe they beat the game together. Who knows? That's a incredible story. Anyway, so kind of getting back to these instructions. So dupes is looking at those first 6 bits, but in the case of like create entities above and to the right, one is doing an addition, the other is doing subtraction, and we miss that data. So what I had been thinking and kind of describing on the channel the last couple days is, what if we looked at more than just the opcode and looked at as much as possible? What if we looked at virtually everything except for globals? But then how do you find globals? And what does that look like? So what I thought was, let's extract a function, just the binary for that function, without any of the other compiler-y things, just the stuff we're looking at when we're decompiling. And then let's create a mask wherever we find global values. So here's a global value. Any of these mapped symbols, we're going to create a mask. And how do we determine what should be masked and what shouldn't be masked? And ultimately, I decided let's just do it based on a heuristic. And the heuristic is a simple state machine that says if you have a load upper immediate followed by a another type of load immediately after it, then we're going to mask out the value portion of that those instructions. And similar, if you're doing a jump and link, we're going to mask out everything but the op. For a jump and link, all 26 remaining bits are used for the address. And so there's a couple more like that, and then there actually is, let me see if I can find any of them. There are some trickier ones, and I guess I don't have any in this overlay, or sorry, this function. There's some trickier ones where the loads are actually separated by an add instruction in between. So they're not always consecutive functions, but I cover that case as well. So I'll undo that. So what you I have a bunch of these up. What you can do then is, so I have the extracted instructions as well as that mask, and I was able to create that mask programmatically now. So I have a small program that that will mask this. Let me just make sure that this is going to generate the same thing. Actually, this is right now. This is just generating the hex values, and then I use XXD to convert. And I have a few extra things in here. So these are just kind of annotated. But then XXD can be used to convert this over right now. In the future, this will just generate the binary mask directly. XXD is a tool for going between hex and binary. And this should have produced the same mask as what I have here already. They do differ. That's because I'm actually creating a tighter mask with those functions, and the other one was handwritten. But then we can come through with bgrep and type correctly. Use those. Did not find anything at all. We can, we should be able to find matches with those. This is completely unplanned. Oh, so that one's too tight. I'll have to go back and see what was wrong with that mask that was created. I did have this working last night, but anyway. Part of this as well is functions for going to the binaries and finding offsets and being able to pull those offsets out into I'm trying to see if I have a command stored in there. It doesn't look like I do. Anyway, find commands there that will match. And I'm a little bummed that I don't have this in my command history at all. But it's really fast. It can go through basically the whole disk in about 1/10 of the second trying to find matches for a function that's pulled out once you've extracted everything. And so the idea, again, is kind of to, when we're pulling new overlays in, looking at how Splat has divided those functions up, taking, building the masks and doing the comparisons of all those functions to things that are previously known and previously built. We don't have to extract everything. We just have to extract the code for that current overlay, which is faster. So basically, it's trying to make adding new overlays faster. We already have nice tooling for adding new overlays, but getting that faster, as well as when we have the matches, making those matches more accurate. Because I know in this RBO3, for example, a lot of the create entities functions end up having misaligned symbols. The symbols are given to a close match that actually should be named something different, and then they have to go back and be fixed up. So hopefully we get more accuracy with that in the future. All right, thank you everybody for joining. I appreciate it. If you're new here, we're decompiling Castlevania Symphony of the Night, and you can go to soten.z.dev to learn more. Really appreciate everybody coming through with the Prime subs. Like I said, what I'd like to do is I try to operate on the games that I have, and I haven't talked to other people to see what other games we all have physical copies of. So I think having physical copies is kind of an important part of this process to make sure that we're operating on things that we can legally operate on. And I'd like to kind of use some of the funds to go to things like that. If you'd like to know more, go to soten.z.dev. You can see the GitHub repo there. The Discord server is linked there as well. You can catch old episodes on YouTube. And if you liked what you saw, please follow on Twitch and subscribe on YouTube. Everybody have a great day, and we'll be back tomorrow. Adios.